All right. So if you want to add a data set to Desmos, I probably don't need to look at myself here. Uh, the little plus sign in the corner is how you add a table. So I'm looking at the table that's in front of you: 3, 4, 5, 6, 7, 8. Desmos is smart enough to figure out that you're counting by ones. It'll figure out your pattern and autofill for you. The next one: 25, 30, 40, 42, 52, 60, 65. So as I've been typing this, there have been points added to this particular graph. Now, if you look at this graph right here, it looks like something. What kind of relationship does it look like to you? Linear. It probably looks linear. Now, the scale's not so great. So in Desmos, the graph settings are found underneath that little wrench in the corner. So the x-axis, I'm just quickly looking at this and realizing that my largest x value is 10. So I'm going to call this, well, we don't know what the data is called. So I'm just going to call it the x-axis, just to let you know and show you that when you type in a label, it goes down here in the bottom right. So you actually have something that you, if you're labeling this and this is months of the year, you should put months of the year. Temperature in degrees, you should put temperature in degrees. Same thing here. We can actually type in y-axis and label that up. Now the scale, there's really no need for me to go lower than 0 because it's all positive. As soon as I do that, things start to look a little bit better. There's really also no reason to go bigger than 10. You'll notice that the graph has changed dramatically. Do the same thing with the y-axis. Now, it's at -5, which I don't actually mind, but I'm going to put it right to 0. And up here, I'm going to go to 70. Doesn't change things too much. If I click over here, how many people now agree this looks much more linear? Yeah. Now, scale's important, right? The scale affects how you interpret the data. So your first step whenever you're doing any sort of analysis and plotting any sort of points is figuring out a scale and posting it appropriately on each axis. The nice thing about Desmos is you can just play with it and see how it looks. I'm going to zoom out just a little, which I always do, so I can see things a little bit better. Now, see if I remember how to do this. We are in agreement that this is okay. So what I typed in was y equals mx plus b. I used that little symbol there, which is found in the top left of your keyboard, and it is, I believe, called sigma, and it just tells Desmos that you are, is that sigma? I don't know. Squiggle. It tells Desmos that you're looking at this data, and it tells Desmos that you want to draw a line of best fit. So that's a perfect linear line of best fit. You cannot do better than that. It's computer generated. In grade 9, you would have taken your ruler and you would have done the same. We'll talk more about residual plots and R-squared values later. But a residual plot tells you how far each dot is away from the line. And in Desmos, if you click that button, it will add that plot underneath. So you'll notice what it does is it plots points the exact same distance from the x-axis as these green ones are from your line of best fit. So the other thing I had to do to get a line of best fit is indicate what data set I wanted to look at. So I use Y1 and X1 because my table is X1 and Y1. That's what I'm using. So if you don't put the little ones on there, it won't look at the right data. So if you put 2 on there, that means you're looking at table 2. And you can put multiple tables on there and look at everything. So just make sure you're telling it to look at the right table. Now, just for fun, we could try some other things. Y1, A, B, the exponent X, 1. So we just did an exponential line of best fit. If I get rid of the linear one, it doesn't actually seem that unreasonable, right? Pretty close. We were all satisfied with it being linear. But we throw the exponential growth on there and we go, you know what, that's actually reasonable. Perhaps that's what it is. The last one that you can, of course, throw on there that we are looking at is our quadratic. And remember our quadratic equation. Now, you can actually put it in any form you want. I sort of err on the side of the vertex form. So as soon as I put Y1, it tells you I'm looking at that 7-element list there. And then I'm going to go A, X1 minus H squared plus K. I think I did that one okay. Check that out. There's our quadratic. Now, here's where things get kind of wild with this. Is anybody familiar with the R squared value? You're seeing it in the corner there. Not radius, but good thought. Not a radical either. We'll do a whole day on this, but basically what the R squared was that? So what it's doing is it's taking this residual plot. It's measuring how far each one is from the line. It's squaring that value. It's a regression analysis. So we're analyzing each of our lines, and it's basically telling you how close to 100% fit it is. So I know it's a little bit difficult to see, or a lot difficult to see because the numbers are small. But interestingly enough, if you're comparing R squared values and you're saying that one would be 100%, our linear one is 0.9878. Our exponential is 0.9752. And our quadratic is 0.9881. So we start overlapping these residual plots. And you can see if I zoom in here, the residual plots, basically the closer these dots are to X, it normalizes everything and lets you compare things. The closer to X, the better. If it was perfect 100%, we would be going right along the X-axis. So you can sort of see the one that's on top, the one that's closest to, like the red one, the linear is closest here. It's pretty much a dead heat. It's pretty much a tie with this data. So that's how you do these plots on Desmos. And your challenge will be in this course, figuring out which one fits the best. Because we've got the numbers here. If you find a relationship that's 97%, like that's really, really good. You plot some data, you're looking for like a cause and effect relationship, and you figure out, you're like, oh, look at this. People who get over 6 hours of sleep a night get grades above 70. You find a relationship that's 97%. That's really, really good. The problem is here, these are all so close. The crazy thing is, we all thought there's no way that was quadratic, right? According to the numbers, it's actually the highest. Now, I don't think it makes sense. I have a feeling that this data isn't quadratic, but I don't know what the data is. So in this class, you're going to have to actually consider what the data is and think long term and give an extra reason as to which one is the best. So you're going to have to use more than just technology to do this sort of calculation. Now, the beautiful thing about these calculators and the Desmos calculator is it gave you the M value, you'll notice. It gave you the B value, you'll notice. And it gave you your A and your B. And down here, you got your vertex point as well and your A value. All calculated, it spits it out instantly, so you don't have to do any of that long form calculation, which is a great tool. The bad news is we still have to do long form calculations. That's enough on the video.